Hi, welcome to Group 20. My name is Bohao Wu. I am presenting with my teammates Shuseng Han and Wenjie Guo. So our project is in development track with the title Document Comparison and Topic Modeling Tool. Our motivation is here. So there have already been many existing tools that focus on the text comparison, but they are mainly superficial copy and paste. So instead of finding such basic overlaps, we want to go beyond the plagiarism and provide interdisciplinary insights by modeling the topics. So some highlights of our development. First, we create a web page, and then we perform the main function by comparing the documents at the level of topics. We can take a better look at this structure. So from the web page front end, we take the inputs of the two documents, 1 and 2, and then we do some pre-process to convert into tokens. Based on the tokens, we perform the topic modeling, either PRSA or LDA, up to the user's choice, but we implemented both. So that after the modeling, we get the topic words distributions as well as the document similarity. And for the words distribution, we feed them into the large language model and get the generated summaries. And then we pack all the results from the models and send it back to the user at the front end. So since the modules are developed by different students in our group, there are two different methods to do the pre-process. The first is to remove the stop words and then tokenize the words and filter out some redundant short words. And then we map the words into the dictionaries and then perform the counting afterwards. The second method is quite similar. It used a different library called NLTK to remove the stop words and then do the tokenization, and also perform an additional step called the lemmatization, where they just combine similar words into the same embedding. So both methods have applied the stop word removal so that for the following modeling, there won't be any background topic. This is a quick overview of PRSA and LDA. For PRSA, it identifies latent topics in the in a collection of documents, and for LDA, it is an extension of PRSA by applying an additional dirichlet prior on the topic distribution. So both models can analyze documents to discover the topics and also provide the inference of the word association from the topics. So this is the tool output from our models. For PLSA, it outputs three things. The first is the most relevant topic for document 1 and its word distribution. So we find this topic by performing the argmax of pi1 over all the topics. Similarly, for document 2, we find the biggest pi2 over the topics. And for the most common topic, we find the biggest product of the pi1, pi2. And for LDA, it's quite similar. The first two are the same. The last one, the most common words, comes from the previous two topics, and then we make the product of the words distribution from the two topics and find the biggest product, so that this word will be counted as the common words.
Next is the similarity. So we first use some embedded models to map the documents into some vectors, and then we will apply some metrics to compare the vector of the two documents so that we know how similar of the two documents. So about on the embedded model, we use the BERT similarity. So basically, we use the pre-training BERT embedding to represent the text. So we encode the text into some vectors. And about the similarity, we use the cosine similarity, which is the angle between two vectors. And we also use the Pearson correlation coefficient to measure the strengths and directions of the two vectors to represent the distance between the two vectors. And next, we used React and for the front end, and we're going to show you the demo.
Hey everyone, this is our application's UI. It takes 2 documents as the input, and let's upload 2 documents. These 2 documents is the news about abolition of abortion. And now click compare. Open the sidebar. On sidebar, we can see the result. This first part is summary. It includes cosine similarity, BERT similarity, and Pearson correlation, possible topic, and common words. The cosine similarity, BERT similarity, and Pearson correlation was used to measure the similarity between 2 documents. Higher the value, more similar the 2 documents. And then is a possible topic. The possible topic is generated by the Google's Gemini. We input the common words. And it is a possibility in, and ask the model or summarize a possible topic. And the last part is common words. At the top of the sidebar is the control part. There are 2 scholars. They are used to control the topic show number and word show number. We can change them to show more topics and word distribution. The maximum to 5 topic show number and 20 words number. You can see the different. And in the control part, there are also 2 buttons. The first button is used to switch the model from LSA and LDA. These 2 different models generate different word distribution and topic distribution. We can see the different. And the second button is used to switch the document between document 1 and document 2. They have different distribution too. And we can change to another document to see the different. Be this. I change the document change one document to children story, and we can see the cosine similarity, BERT similarity, and the Pearson correlation is almost 0. And that is all of our applications demo. Thank you.